Welcome, everyone. My name is David Evans. I'm the chair of the Hazardous Industries Group, and today we're joined by Matt Clay. Just before we actually start Matt's presentation, just a couple of quick words on the housekeeping side of the Hazardous Industries Group. We love you all to get engaged with us. We promote through LinkedIn and Twitter information. LinkedIn is the big one that we get a lot of information out on. And information and networking relies on as many of our friends, you included, to share information with us on new issues, items, stories that are of interest that can benefit safety across Hazardous Industries Group. Now, we're at that point in the Industries Group where we've got thousands of you with us on LinkedIn, and the demographics of the group are growing considerably. And it's time for us to sort of issue a standing request, please, for any of you that would be really interested to get involved in the committee and help us, maybe serve on the committee or become a friend of the committee and help us with information. We're trying to encourage diversity. We can do with a lot more youth, a lot more people with different backgrounds to help us. So look out for my chairman's note on that. And please do get in touch with me when you receive it. Now, this is coming towards the end of 2021. We've got a really fascinating program that we're pulling together for next year. And the theme as part of that is to try to engage with external organizations and groups as much as we can. This year, we had the safety center involved. Next year, we're hoping to get the Environment Agency and the Process Safety Forum, maybe even the Chemical Industry Association, to come in and give us a talk about all the work they're doing in the safety field on hazardous industries. And those webinars will sit alongside the practical side of dealing with process safety, confined space, possibly into energy and hydrogen usage as well. But for today, I'm really pleased to be able to introduce you to somebody from the hazardous industries, right at the heart of it. In other words, the health and safety executive. And some of you will remember that Matt Clay was one of the one of the previous chairs of the Hazardous Industries Group. He did such a sterling job that I felt I had to take over. Is that true, Matt?
Absolutely. Well done, David. Big shoes to fill.
No, great. Matt had to stand out. All the pressures on his role, particularly with the COVID problems coming in, and he passed across a really good committee and a group that's been very, very healthy. So, Matt, I'm going to be quiet now. I'll come back and help on the questions. So I'm going to hand over to you for a very interesting talk on loss of containment. Take care. Thanks.
Yeah. Well, thanks very much indeed for that, David, and good afternoon to everyone. So I'm Matt Clay, as David says, and I work for the Health and Safety Executive in the Science Division of that organisation. And I just want to talk to you for about 45 minutes, after which there'll be a question and answer session, just on a project that I'm leading, which is the Loss of Containment Insights project, which is part of a wider programme of work. And those of you with an eye to detail will see that the presentations in the Discovering Safety format, and I'll take you through what that program is about, because it might be of interest to some of you more broadly than this. But my specific project is looking at loss of containment in the process industry, so it's basically trying for us to improve process safety standards. Okay, so basically this is an overview which describes how the Discovering Safety program works. And the Discovering Safety program is really all about learning from chaotic and unstructured data sets, and in particular, those involving free text. So we know that a lot of work has been done in the past about collating and organizing coded data which is categorized already. That has some advantages and disadvantages. The Discovering Safety program is a recognition that there's a lot of information held within industry and within regulators, which is not codified. It's in quite a chaotic state. It's free text, it's documents, it's reports, etc. And so what we're trying to do is use some cutting edge analytical techniques to extract value from that unstructured data. So we've set the Discovering Safety programme up to deliver that. And the programme is supported financially by the Lloyd's Register Foundation. Many of you will be familiar with Lloyd's Register, which does a lot of work within shipping and all sorts of different sectors, and acts as a verifier and consultancy firm. What I wasn't aware of before this project started was that actually the foundation, all of the funds are paid into the foundation, and the foundation basically helps other people to set up programs of work to improve global health and safety across all industry sectors. In order to deliver this program, we've set up an institute, which is the Thomas Ashton Institute, and that's really a collaboration between the Health and Safety Executive, which is the Great Britain regulator for health and safety, and also the University of Manchester. And there's a particular strength within the University of Manchester in terms of their ability to do text mining and natural language processing techniques, which we require for the project. So it's a very exciting project, and there is a website for Discovering Safety. And as I said, there are many more projects than I'm going to talk about today involved in that, many in the construction sector, which I know will be of interest to many of you. So feel free to have a look at that, and I'll put a link into that at the end. So just in terms of this project, the Loss of Containment Insights project, then, I probably am preaching to the choir, hopefully, to some extent on this in terms of the importance of avoiding these events. But clearly what we're talking about here is preventing fires, explosions and toxic releases. And here are some examples from around the world in terms of some of the worst case sort of events that we've seen. And so probably, as many of you will be aware, the worst industrial disaster, Bhopal, India in 1984, where, as you recall, loss of methyl isocyanate, a toxic material, which led to many offsite deaths, officially around 4,000. But of course, as you'll know, there was a lot of chronic ill health that resulted from that and further deaths that occurred. So many estimates put that much, much higher than the official estimates. And closer to home, of course, feels like only yesterday, the Buncefield explosion at the fuel storage depot, which happened in 2005. Fortunately not resulting in any deaths to people, but clearly there was a massive economic impact which was associated with that site being a site of strategic importance for things like aviation fuel and so on. So massive economic impact there. And then also within the maritime sector, we have this floating production, storage and offtake vessel back in 2015 in Brazil, which resulted from a leak of gas condensate from a pump. And that sadly resulted in 9 deaths and a 200 million sterling equivalent repair claim. So these are very important events. It's important that we try and prevent and mitigate those as much as we can. And in order to do that, we're trying to extract insights from data that would otherwise just be sat there doing nothing effectively. So some of you will be familiar with this pyramid, which basically takes data to wisdom. So just to briefly describe this, so data is effectively, I would liken it to a bucket full of stuff. Basically, you've got lots of individual records. Companies may have incident reports and so forth. And that's really sat there in a repository, whether that's a database or on hard drives or in the cloud or whatever, relatively unstructured, and it's just sat there. We then attempt to sort of codify and categorize that data to give it some kind of meaning. And obviously in traditional approaches, people have done that manually, and they've chosen from drop-down boxes, for example, in databases. Within the work we're doing, we're trying very much to extract data from free text, which is a lot more challenging. But the overall aim is that we develop knowledge, which is a more generalizable learning from experience. So we may know, for example, that most aging plant related issues involve, say, pumps, for example. That would be an insight that would give us more generalizable meaning from that data if we were to discover that. But then what we're really seeking is wisdom, and wisdom has been called actionable insight. And really what wisdom is about us improving practices today to prevent the sort of events that we're trying to avoid. And probably a good example of wisdom applied in another setting is that we obviously all know that in raising babies are now put to sleep on their back, and that's realization, that is wisdom, because that arises from the fact that that's a much safer sleeping position. And obviously that wisdom has developed from an enormous amount of analysis of individual information and data. So really, as we go up this pyramid, we're trying to effectively improve practice. The challenge for us, of course, is that the data we're dealing with is extremely chaotic and difficult to assess, and that's really what the project is all about. So as part of the project, we've developed a reasonably simple sort of way of codifying how a typical process safety incident progresses. And this is important because we use this in order to train our methods to extract the relevant entries from the free text. So we have on the left of this the underpinning hazards. So these are flammable and toxic materials, for example. They're sat there, and normally in primary containment, we're perfectly happy with that. But then we have initiating events, which are basically things which are not in and of themselves dangerous, but can lead to dangerous circumstances. So these would be things like an operator calculating the free space in a tank incorrectly, or an isolation valve sticking open or closed, depending on what it's doing. And these lead on to deviations, which those of you with experience in HAZOP will recognize. And these are deviations from the design envelope of the plant. So things like overpressure, over temperature, reverse flow, these sort of undesirable conditions. And these, if unchecked, can lead to loss events, which are basically irreversible physical conditions. So things like runaway reactions, tank overfills, and so forth. And these in turn lead to impacts, which are effectively undesirable outcomes for both the people at the plant, the people off-site, and also the environment and assets, etc. So this is the basic model that underpins the work we're doing, but it's important that you don't think of this purely in terms of applying this to looking at incident reports, although we are certainly doing that. But we're also very keen that we use this approach to look at other sources of documents. So there may be, for example, HAZOP reports, there may be audit reports which describe the effectiveness of prevention and mitigation barriers. And we're very much hoping that we can use this to extract relevant insights from lots of different pieces of information, not just when something has actually gone wrong. So this is effectively what we're doing, and we're starting off using HSE's own data. So we have a database within HSE which inspectors use called the COIN dataset, and that records a lot of regulatory interventions within the process industry and wider. And there are basically within there lots of document attachments. So there are documents that inspectors generate, but there are also industry documents. So for example, internal incident investigation reports and audit reports, and lots of different pieces of information within that data set. Unfortunately, like many data sets, this was created to provide a sort of repository on a site-by-site basis, and it wasn't designed with insight and intelligence in mind. And so what we're having to do is to effectively take source documents, so these could be PDFs, emails, word process documents, and spreadsheets, and then we extract from that the raw text, which it basically allows us to progress that with further methods, basically. And one of the things we very strongly advocate is what's called a supervised learning environment. So we're always involving subject matter expertise. So for example, process safety specialists, other engineers, to really give us a handle and a sort of reality check on providing some of the insights. So we're very much doing things and reviewing them and making sure that they're actually making real world sense. And the idea is therefore that we basically take the raw free text information that we start with, extract the text from that, apply the methods, and then we extract those features such as deviations, loss events, and so forth, and other underpinning things such as, for example, which industry sector the event happened in. So just in terms of some of the rationale for doing this, why do analysis of free text data at all? Why not just stick with codified data? Well, we know that organizations increasingly store huge quantities of data for long periods because data storage is now extremely cheap. And there's also data which exists, which isn't created with safety in mind, but still could be used potentially for that purpose. So, for example, asset management systems is one key example. But I think perhaps the most important reason that we need to do this is that we know that field colleagues are very time poor. You know, many organizations are run on quite lean principles these days, and getting people to try and develop coded, elaborate database systems is basically a non-starter. So the information typically is existing in this free text format, and we need to try and extract information from that without putting burdens on users. But of course, trying to do this is extremely difficult, and we've got the panning for gold image there, because this does feel like that sometimes, that quantity is not quality. Not all detected patterns, automatically detected patterns, are useful. So if, for example, you discover that most fires involve a flammable substance or something of that nature, then that's not particularly helpful insight. And there are some hilarious examples from machine learning and other applications where patterns have been noticed which are blatantly obvious and of no use to humans whatsoever. So we do need to be careful about that. The other challenge we've got, and I'll come on to some more specifics about this, is that coded data can be desensitized. So if you had a spreadsheet of information and you had people's dates of birth and home addresses, you can quite easily remove those fields. With unstructured data, free text data, it's much more challenging because of the way that things are written and the fact that there's multiple permutations, many different names and organizations and other ways which organizations and people can be identified. So that's challenging. The other thing is, of course, that many of these processes that we're trying to use are not created with science and engineering in mind. And in fact, most of the text processing techniques are based on things like social media, news, politics, etc. And we've seen this very early when we've tried to apply these techniques to this unique application, that it is quite clunky and we do need to do things in a slightly different way. So that is challenging. And then there are some problems which are so inherently difficult. If I was to show all of you on this call a number of incidents and ask you to come out with root causes, there would be a very wide spectrum, I suspect, in how those were described. Well, imagine getting a machine to do that effectively is very difficult. So one of the early findings, which is of no surprise, I'm sure, is that getting technical insights out in terms of initiating events and amount of substance lost and things like that is relatively trivial. When it comes on to the sort of the really difficult things in terms of root causation, then it becomes much more challenging. And the paradox is, of course, that we're probably more interested in that root causation than anything else, and that's the most difficult. So it is difficult, but there are various tools that we can use, and there's a spectrum of techniques from the simple to the complex, and this just shows the sort of start of the process. So this is what I call basic text mining, and it's frequency analysis, and it's basically using just the occurrence of words and how popular they are to extract some basic information about a piece of text. And you'll see this word cloud thing in many publications where it just gives you an overall flavor. Useful for some things and useful to give you a quick insight into a particular document or whatever, but it's not particularly helpful in science and engineering and in deep topic specialisms such as process safety, where we're wanting quite a lot more information out of this, but it is a valid technique. We then move to the sort of the other extreme, or starting there, which is something called natural language processing. And this is really underpinned by how English or other languages is structured. And so basically the machine learning tools which run this natural language processing will take a sentence like the high level trip failed, which could come from HSE's own data, or it could come from industry's data, and it basically breaks it down into the different parts of speech, as they call it, which are things like nouns and verbs and the other parts of speech that are made up. And I have to say, this has been an interesting development for me, because I wasn't particularly a grammar expert at school, so I've learned a lot about how English is structured, and of course the other challenges as well, that people don't necessarily follow the rules. There's lots of spelling mistakes and bad grammar and things, so these techniques don't work with 100% effectiveness, but using these techniques is generally more reliable than the more simple text mining techniques. And then at sort of the cutting edge of natural language processing techniques, we're looking very much at what's called entity extraction. And this is an example, and you can have a look at this yourselves on the internet, of a entity extraction applied to construction. So this isn't specific to my project, but this just gives you an idea. So the colleagues at NACTEM at the University of Manchester have developed a tool which they've applied to RIDDOR reports, which basically will show that various different things can be extracted. So for example, here we have construction activity, equipment, physical environment, and so forth. And if you go onto that site, the NACTEM site, you can very much have a go and have a play and see what comes out. But that's really our aspiration for the process safety aspects as well, is to extract those important entities as well. And those of you who love whiskey should look away now, I'm afraid to say, because this is a terrible incident involving loss of an intermediate to whiskey. So may come as a surprise to some people, but actually whiskey distilleries in the UK are often subject to the COMA regulations because they involve storage of such large quantities of highly flammable liquids. And this is a loss of 2,000 litres of spirit following a smashed sight glass. And basically this has resulted in loss of product to a bund. But you can see this hasn't been subject to any automated processes, but this is just a manual explanation of how we might extract those entities from free text. So we're able to extract things like the quantity and substance lost, initiating events, so in this particular case a smashed sight glass, a deviation, which in this case is basically other than flow, as we'd call it in HAZOP. So this is basically the flow of a product to somewhere where it isn't meant to be. But also you can see here that actually, although this is a horrible incident, no ignition resulted, and actually there are a number of safety features which have actually worked very well as intended to minimize and mitigate that event. So again, there's intelligence in here that we can use potentially to that actionable insight, so we can actually look at not just failure but actually success. How are loss of containment events successfully mitigated, and what can other people learn from this? And obviously the power of this work is if we take thousands of records and we can reliably extract these entities from free text, then we start to create connections and patterns and that actionable insight across the industry, which is quite exciting. So where we're at here is that we've developed a core screening tool, because one of the challenges we have is that often we don't know whether something is a process safety record. That might sound a bit strange, but oftentimes they're lumped in with other occupational safety records. So our core screen enables us to have a very quick look at a particular document and decide whether or not there's actually anything of value in there before we apply the sort of processing intensive NLP techniques to that. We've also benchmarked some key industry standards, so not to replicate them, but just to make our output compatible with them. So for example, many of you will be aware of the API 754 standard, which is the American Petroleum Institute. And whilst that is created with key performance indicators in mind, it also has some interesting taxonomies for things like equipment types and loss events and so on. So again, we're trying to make this not replicate other things, but be compatible with them, because our ultimate aim is to provide users with a tool by which they can search for relevant insight for their sector, or indeed across other sectors. We're working with about 16,000 free text records at the moment, but we wish to expand that. And we are using NLP techniques, as I said. Some things are easy to get out, some are more challenging, and we've been working with the University of Manchester to try and explore some of the more high-end NLP tools to make this somewhat easier to do. So this gives you just an illustration of the relative ease or otherwise of what we're trying to get out of this. So if we take free text and we're after looking at for quantities of materials, which is a common thing that applies particularly in the incident space, then we have relatively easily been able to extract things like 250 litres, 4 tonnes, and that sort of thing. Obviously, there's many ways of describing the same thing, but broadly, using some of the techniques we've got, that's relatively easy. Similarly with substance, again, it's a question of really looking through a chemicals database and looking at what exists in the text. Again, relatively straightforward. We then come on to sort of substance lost. Again, slightly more challenging, but not particularly difficult. And then when we come on to things like initiating events, that becomes somewhat more hard, but not impossible by any means. And it's then really when we come into these other features, for example, deviation. What we tend to find in the descriptions of events is that people don't necessarily put in the deviation in a sort of HAZOP 1 or 2 word sentence. The deviation will be split across text, and it will be you might get the design intent of a piece of plant somewhere and then an indication of what's gone wrong across many sentences elsewhere. So this is actually quite a bit more challenging than I think we were expecting it to be in the first case. And similarly with the prevention and mitigation barrier effectiveness, often quite reasonably, incident reports will describe in detail the barriers that have failed or worked. And again, there's quite a lot of narrative around that, and often it takes you quite a long time as a human even to read that and extract the relevant insight. And obviously we're trying to standardize this across many different records, so that is particularly challenging for us. And then similarly, we've got things like impacts are relatively straightforward because that tends to be described in a fairly sort of punchy way. But you can see that the ease or otherwise of extraction is quite variable depending on what we're trying to get out. So I think this is exciting work that we're doing, but obviously it's not without its challenges. And the other interesting development, and I don't know if there's anyone on from the nuclear sector, but one interesting finding when we started to do some stakeholder consultation with this work early on was that we got some interest in this from the civil nuclear sector. And as you'd be aware, that the nuclear sector focuses a lot on nuclear safety, radiological protection, and it also it looks at conventional safety, as they call it, so workplace transport, etc. But they do have their own process safety hazards, very much. They have storage of bulk quantities of flammables and toxics and so on that are used for all sorts of things, including water treatment and other things. And they use this slightly different terminology. They use this phrase chemotoxic to refer to the hazards that we would effectively call the management of process safety. So there's lots of different terminology, but there's lots of commonality. And there's also another good thing with the nuclear sector, which is they do actually have a long history of publicly publishing lessons learnt and chemotoxic insights. So that's very useful. And what we hope to do is to help industries learn from one another, so to get across those traditional boundaries which get in the way of working together and actually improving things. So just as we sort of nearer the end of the presentation, I just want to talk about data sharing, because this is really an extremely important aspect of the work and one that's really key for us to overcome, really. So as I said earlier, we're looking very much at using HC's own data for this work, but we're very keen to augment that with industry's own data. And we found this to be quite challenging. You know, we've had some quite candid discussions with people within industry, and some of my colleagues on the construction occupational safety projects have been actually quite successful in working with the construction industry to share data on occupational safety issues. The feedback we're getting is that major hazards data sharing is more challenging, and there's a suggestion that some of that's around sort of reputational impact and sector reputation. and so on. And also the relative infrequency of the events that happen in process safety mean that the higher consequences events that attract the most learning are so specific that it would be obvious from those descriptions as to which operator it was. So we are trying to work with industry, and one of the key things we're interested in is to unpick this more. And I've launched a survey. In fact, I've launched that today, and I'll talk to you about that in a few seconds. But we're very much keen to get people's honest feedback on this particular data sharing issue, because that is one of the key things that is important in order to make this a success. And in fact, we've reached there sooner than I thought, actually. So that's just a description of the Loss of Containment Insights project, but I'd be very interested to hear some of your questions, observations, and so forth. And I do, as I say, we're piloting this survey on your good selves at the Hazardous Industries Group, because obviously of your sort of experience. And so that survey is launched today. So if you do have a chance to do that, the survey is split into two sections effectively. One is about what insights you would like to see from this project, which is important. And then obviously the other bit is this key issue around data sharing and your attitudes and your organization's attitudes to data sharing. I have tried to make the survey punchy because I know you're all extremely busy people, but if you do have time to fill that survey in, that will be very much appreciated. And I don't think you can click that link in there, so I will put a copy of that in the chat function as well. But I shall pause there, and I guess you'd probably like to come back in there, David, and we can take some questions. Thank you.
Yeah, hi, Matt. Can you hear me?
I can indeed, yeah.
That's always a good start. But the bits I did manage to catch are absolutely fascinating. And you're sort of laying out almost, I think, a foundation for the way that we move forward in safety. I mean, to me, big data is that pile of material I've got sitting on my desk that I know there's interesting things in, but I can never get to the grips of what's there at the time. One of the things that struck me as you were going through it that I'd like to open the question before I start reviewing other people's is that you've told us that you're gathering data through the search of free text. Mm-hmm. Can you look at timelines within that? So, for instance, can you look at the length of time or duration from a release to intervention or through detection? Is there an ability to go that far?
Yeah, I mean, I think in theory we'd like certainly to be able to do that, because that's, I mean, if you think back to the whiskey distillery incident, obviously that was a large release, but it was mitigated, and I think there's different aspects to that, and one is the sort of time-based one, how soon prevention and mitigation barriers actually end up having to take to actually work properly. And so I think that that would certainly be an interesting one. One of the things I suspect that sort of timeline aspect is one of the more difficult to extract features, because again, anything that's an entity in itself, like a quantity or something's relatively easy. Anything that's spread out around a paragraph, for example, is more challenging. So basically we as humans tend to tell stories, don't we? And really the text mining and natural language processing it can do that, but that's at the more complex end where you've got that sort of that description. But in theory, there's no reason that we couldn't, and that would be very, very valuable. I think that does illustrate this point of the fact that more valuable insights is actually the more challenging things to extract, which is a shame, because it would be wonderful if it was dead easy. But I guess that's why we set the program up, because we knew it would need quite a lot of thinking time to get this to work, really.
It opens a Pandora's box, really, doesn't it? I mean, I'm already saying I'd really like to know what was the method of detection. Is it, pre-planned gas detection? Is it process indicators? Is it an operator wandering past? Are we seeing trends across these?
And one of the challenges, of course, with that, David, is that the quality of which people fill in reports and things is extremely diverse. So you'll get people that are sort of have what I call the forensic mentality, where they basically are putting quite a lot of information in quite a structured way. And then you'll get other people that are doing quite superficial sort of investigations into things. And obviously that's a challenge in its own right, but it's also challenging in that you kind of need to know when that information just isn't there in the text, which often is the case as well.
Yeah, no, well, in fact, that ties in nicely to the question Matthew Murphy raised, which is, are you thinking about, or is it possible to give front-end guidance to people on the way they submit reports, or, the sorts of reports we should all make a summary note of?
Yeah, I mean, it's a real challenge, this one, because I'm sort of conflicted on this one, because obviously from a selfish point of view, I'd like to just say this is the best way to write a report, or even an audit, let's say. But the pragmatist in me says that if we do that, it's unlikely to happen, and also if it did happen, it wouldn't be consistently applied necessarily. So I think the idea with the free text extraction is to minimize burdens on field staff effectively, and trying to work with not letting perfection be the enemy of fit for purpose effectively. Yeah. So I think there is a tension there between things, but I think some degree of standardization would be helpful, but I think we also have to be mindful that might not actually develop itself brilliantly. And I think one of the pushbacks I often get on this project, particularly from people in science and engineering and deep topic specialists, is what's the statistical significance, how confident are you in the results, and so forth. And actually it's quite a difficult question to answer, because the actual techniques themselves, in terms of breaking down English into its component parts, are very reliable, probably in the sort of 95% plus margin. But actually, when you start extracting specific things from that analysis of the structure of the text, it actually becomes much more difficult. But I think one of the things we're used to dealing with in engineering is relative risk. So I suspect that the sort of insights we get out of this is not necessarily absolute risk. So for example, equipment failure frequencies, because that's very difficult to see how that would work, because you'd need to know the population of the underlying plant and equipment and so on. But actually, relative information is also useful. So if you were to, I don't know, and this is just an example, but if you were able to find out that in refining that startup and shutdown accounted for far more events than aging plant, for example, that would be a useful finding. Or if you found it was in fact the opposite way around. So it's about giving people a bit more information and insight. And I think the other thing as well, of course, is this project is not meant to be a substitute for all the other good stuff that people are going on doing, things like looking at guidance and standards and the usual business as usual process safety improvement. This is trying to give people that little edge to possibly say, well, actually look over here, because you might not, this is not on your radar, but actually we know from the data it's important. So yeah, I think that phrase about not allowing sort of perfection to get in the way of fit for purpose is an important one.
You mentioned language there. Does it translate into our American cousins, or can you apply it to everywhere from France through India and the Middle East?
Well, that's a very good point, and this is going to sound some awful colonial sort of thing, but a lot of the NLP sort of methods are trained on English, and they're basically there are a lot that will also work with other languages. So in terms of actually the breaking down of a language into a sort of a common language, that's relatively straightforward. But of course, what happens in reality is that we describe things in very different ways, and particularly within engineering and the sort of plant terminology, that can be very difficult. So and also the effort involved to develop new NLP techniques for unpopular languages, shall I call it? I'm trying to be careful what I say here, but
You're trying to avoid Welsh.
Indeed, absolutely. We'll definitely do a Welsh one, David. But it's very challenging to sort of make that work well without starting to really create an awful lot of work. So many of the natural language processing techniques are trained on things like 30,000 sentences or more. So actually, it's not a trivial thing to actually start. But there's no reason that in time that couldn't be resolved, because Lloyd's is an international charity as well, and it's very keen on the global dimension, and that would be brilliant if we could do that. Yeah.
I think that there could be a chance for the audience today that some people would like to get involved. Matthew Murphy's come back on the chat line to say that he'd like to find out how to get an organisation interested, and perhaps you'd like to follow up with that with him after the talk. We will make the chat things available to you, and I know in the past we've been able to allow people for you to follow up on a number of the questions. There is a feedback on the webinar for everybody who's online, but we'll continue with the chat as you fill that in. Your feedback is very important to us. Richard Elvin asks a question, and I think it sponsors, if you like, a follow-on to what I mentioned earlier. And he's asking about the best methods of storage to avoid levies, which is a very specific type of question. But if I can sort of expand that, say, how would you take a question like that and apply it to your perfect situation of a large database of knowledge that you've gathered and the wisdom that you referred to earlier that you can pull out of it?
Yeah, thanks, David. So I think that's a very interesting question. I think so for example, a levy will typically happen on things like, for example, an LPG bulk storage tank with a impinging fire underneath it. And I think there's various aspects we need to pull out. So one of those is clearly the sort of plant and equipment. So you would need means of reliably extracting bulk LPG cylinder or storage tank from the free text. And then obviously you would need to as I described with that incident progression flow chart, you would need to be able to extract all of the relevant sort of parts of the protective mechanism. So for example, one of the things that's sometimes used in prevention of levies is water deluge systems. So again, it would be excellent to know, for example, if through our analysis of the free text, if there are, both in LPG and other applications, how effective are water deluge systems, for example. Now, I know there's guidance and research done on that anyway, but again, it's something that you kind of don't know what you don't know, in that if you may well be surprised by what you find when you can start looking at that things. But again, it all comes back to fundamentally the analysis of that free text and stripping out the relevant features. And again, it's not something that we've yet got to the point where we can say, well, actually, we know from review of 1,000 levies since whenever in free text that we know these features are. We want to get to that position, and I think the ultimate goal is to provide some kind of portal by which people can extract this sort of insight in a wide way as possible. But we're not quite there yet. But certainly those questions are very much the sort of questions that we would like to be able to answer, and do fit in with the process of extraction of hardware failures.
I mean, that must lead into the frustration that, if you take Richard's question, we'd really like to know more details of the hazardous substance or mixture, the thermodynamics, the temperature, the pressure, its containment, and the resulting nature of the incident, both from causation all the way through to end effects. And of course, you're never going to have all that, are you? You're going to have this mix of good information, bad information, and partly present information. How do you fill gaps in, or how do you live with those gaps?
Well, I think that we are looking at sort of inference, so you can infer certain things, not with 100%
Okay.
confidence from certain descriptions. So like overpressure, for example, you can infer from certain words, for example, like burst and things like that, that it may be an overpressure, even though that's not explicitly stated. But obviously, it's the old thing, garbage in, garbage out, still very much applies, in that if the data ain't there, it ain't there. So and again, I think there's a wider piece, isn't there, on the quality of, for example, investigations, and we know that there's a huge variety in the quality of how people do internal investigations, and personally, I think that a lot of that's about their own curiosity about the world. I don't think it's necessarily all about formal investigation training. I think it's about someone's aptitude for finding out things about the world that's important. So I think certainly the more information that's there in the free text, the better. And some of these things are inherently difficult to get out. But again, I think at the moment, we've got, I would argue, relatively poor cross-industry sharing in the onshore process industry. So I think you can argue about that offshore, but I think it would be nice to try and start to do that cross-sector learning in a way that doesn't embarrass one particular sector or operator, but actually that we can start to share this without putting those new burdens on end users to fill in some database after each shift or whatever.
Yeah, I mean, there's my frustration years ago was there's a lot of good information held in particular companies. There's a lot of good information held in some what I would call trade industry groups, but they don't necessarily share them or open access to them to allow that to come. Stephen's raised an interesting question, because process safety isn't just applied to what we think of the main hazardous industries of chemical, oil and gas, etc. And our group is very broad in that definition and widening it really to many organizations that handle some form of energy issues, chemicals in the widest sense of from storage onwards. Now, he's approached it from the water industry side of things. So is there a move for you to look at taking the lessons you're learning here and applying those to the wider industry, whether it's energy generation and distribution, whether it's the water industry or elsewhere?
Yeah, it's a great point, and yes, the answer is that we've actually done what we've called an industry segmentation. So we've not just looked at sort of broad industry categories, we've looked at detailed ones. And so, for example, we've looked at, and they're probably not how you'd conventionally like economically segment an industry, but the things like, the tank storage side of things. We've engaged with Tank Storage Association on things like that, and also energy, downstream oil and gas. And as you say, if you think back to, there have been events, LPG explosions being an obvious one, which have happened in sort of major hazard sectors, but they've got like a little utilities part of their factory which is effectively involves major hazards. So I think we want very much to be as cross-cutting with this, really, for two reasons. One is to get that that sort of wider learning, given there's relatively few sort of events, if you like, but also I think that helps with the data sharing and some of the concerns around that, because if you've cast your net so wide that it's impossible to identify people from the insights you're getting out, but yet still get useful insights, because the definitions and are quite arbitrary. So, for example, with coma, for example, if you store 50 tons of a substance in a particular table, you're in. If you store 49, you're out. And obviously, there has to be that system to put the cutoff somewhere. But clearly, there isn't a sort of step change in risk or hazard profile for just because you're inside or outside a coma. And again, we're looking as well at some of the new work, and we were discussing hydrogen before we came on, weren't we, David? And I think there's a lot of industries where traditional there are new hazards basically in industries which wouldn't conventionally have been thought of as major hazards. So we're very interested in that aspect, and I think That's one of the reasons we did the segmentation exercise. And you'll also see, for those of you that complete the survey, that there is a drop-down list of industries, but that's not exhaustive, in that there is another box which will enable people, and we're keen to hear from people in as wide a spectrum of industry as possible. So yeah.
I mean, another point that Stephen raised is that many industries tend to approach all incidents in, if you like, a traditional health and safety perspective. So let's fill in a riddle form, for example. But actually, if you approach it from a process safety hack, you tend to see a much wider set of questions and positioning made.
Mm.
And the work that you're doing, if sort of shared broadly, would it start to challenge the way that we actually see and think about incidents and prevention, precaution, barrier, which in a lot of industries, that language doesn't necessarily translate into the way they approach their problems.
Yeah, I think that's right. And I think one of my perennial irritations is that we target, or I say a lot of organizations, not all of them, but will target harm for investigation rather than the potential for harm. So for example, they'll look at serious injury riddles, and they'll look at the sort of fires, explosions and things, but actually we know that there's a lot of high potential events that happen, which actually sometimes seem on the surface really trivial, but when you start to approach them from a sort of laser protection perspective, and you start looking at just how many barriers have been eroded, and some of the common linkages between barriers, where you can take a whole suite of barriers out through one common mode or common cause failure. When you start to adopt that mindset, you kind of get a much richer understanding. And there are some high harm events with very little learning that comes out of them, and there are also similarly lots of events where no harm occurs, where there's a huge amount of learning. So I think that that's known amongst certain people, certainly, and obviously some organizations are much better at that, but I think there is still a culture there of not unpicking some of the lesser harm but very important issues, definitely.
Okay. My final question, because I know we're coming up to the hour, it interests me, is that you've obviously created your database of info, and you've got the tools, the NLP techniques to search. Is it ever going to get to a stage where I could advise a client, or if I work for a company in any sector, could I come to you and borrow that software and run it on my internal database of freestanding information to see what I turn up just for me, so I don't have to persuade my bosses to release all this so-called private information, or I can sweep across the company?
Yeah, that's a very astute question, because that links very much to one of the questions in the survey, actually, because within the survey, there's various different potential solutions to this problem of sharing. And one of them is exactly as you described, David, which is basically to not release free text information from any company directly, but effectively to run, as you described, software on the sort of the estate, the IT estate of the organization, and that just basically spitting out to some repository, or well, one, providing insight to that operator that's actually running that, but probably more important for the greater good is spitting out some codified insights which could never be associated with that organization. That would really, that's one of the ways we can potentially address this. Now, there's two obvious problems with that approach, of course. One is that you have to run some software on your own IT estate, which obviously creates some barriers. And also the other thing is that in terms of searching, if people are wanting to run bespoke searching, then you can only run that on the sort of codified insights. So you have to make sure that the NLP techniques are running relatively well, and that they're spitting out enough information that people can search on that. So there's lots of different models. There's also, we've developed with a company called Ohalo an anonymization algorithm, which basically takes out personal data and location data and that sort of thing. Again, none of these things are absolutely foolproof, and that is one of the challenges. It depends on your sort of appetite for risk, really, because as I say, they're not perfect. But I think my gut feeling is that there'll be a combination of techniques we can use to try and address this data sharing problem. But one of them is exactly as you've described, and there are others as well. And there are other things around who owns and keeps that data in a repository, and is that a trade body, or is that what's called a data trust, which is a special limited company set up to so there's lots of options, and I think what we're keen to do is to understand them so that we can actually come up with something pragmatic that's going to work for people and that isn't going to sort of scare people off, really. So it's certainly very interesting.
Thanks, Matt. It's been a fascinating session, and I can see a lot of the hard work that's going into this. And I suspect we're going to have you back at some time in the future to tell us more about the results and more about the details and the examples that you're finding, because I've got a feeling that it is going to turn some of our preconceptions about what fails, when it fails, and how we get leaks on the head, and make us think about what is going on. So at that point, I think it's enough to say, goodbye from the Hazardous Industries Group today, and thank you for joining us. We will review any additional questions, but thank you all for participating in the session, and we look forward to seeing you when we next have a webinar. So take care, everyone. And Dimple, thank you so much for running it. Take care. Cheers.